Hello dear viewers, welcome to TV Math. In our today's session, I will be taking you through Kamasa Joint Mock Examinations, Principal Mathematics Paper 1. So Kamasa stands for Kampala Integrated Secondary Schools Examinations Bureau. This is the mock examination that has been done by the mathematics students from the schools that subscribe to Kamasa body. So for those that did this paper, we welcome you all from that paper, and I hope you found this paper very friendly. We shall be looking at each and every item in this paper. So please, for those that did this paper, you are highly welcome, and please make sure you watch this video up to the end. And for those that start for different mock bodies, this mock is surely important for you. So please, as TV Master, we are committed to bringing to you each and every mock that has been done. So make sure you subscribe to TV Math. So far at TV Math, we have already digested some of the mock papers. For example, we have already looked at Achiyeteka Joint Mock. This one here, Principal Mathematics Paper 1, we have already looked at that. Each and every item in this paper has been solved. We have already looked at Paper 2 from TV Math. That is also a full paper has been completely solved. And you find it here, free of charge. Simply come to TV Math and go through the videos. You will be able to get the video that you are interested in. But for those who are in Senior 5, you are in Senior 6, you don't need to miss any of these videos. There is also a mock paper that has been as well solved at TV Math. So this is also a level math 2026 mock paper 1. Every item solved. So we have as well already solved that. We have looked at Kamasa pre-mock. It is already there as well. So there shouldn't be any excuse of you failing to get the required grades in mathematics when TV Math is doing all it takes to make sure that you go into the paper with knowledge on each and every item. And remember, the many items you solve, the more you get the confidence to attempt each and every item whenever you go to the paper. So please come to TV Math, check for these videos. For those who are in Senior 5, and of course it will also be helpful for those who are in Senior 6 already, Senior 5 Principal Maths Paper 1, 2026 Term 2, Mid-Term 2. For those who are preparing for their end of term, those who are preparing for mid-term, so please go through these items. You will be surprised to find the same items within your paper, and you'll be like, oh, I saw this one at TV Math. It won't be helpful by then. So please make sure you use this opportunity to go through some of these items. Very many items have been uploaded at TV Math to help you in your preparation for your final examination, in your preparation for getting better grades at A level. So come to TV Math. Very, very many videos have been uploaded, and it will be absurd if you leave TV Math without subscribing to it. Subscription is completely free of charge. So please come to TV Math, subscribe to the channel so you can always get updated whenever a new video is uploaded. Without wasting time, let us look at our today's joint mock examination. So this is Kamasa Joint Mock Examination. For those that are here for the first time, TV is my name, and I can be reached via this contact. And the good news is we already have a WhatsApp group that is joining all the A-level students. If you are in Senior 5, you are in Senior 6, and you haven't joined that WhatsApp group, surely I don't know what you are waiting for. Joining the group is completely free of charge, but you will get a lot of resources from that group. I will put the link in the description so you can join the group before it is full. It is almost full, and please, this is already almost the second. This is the second group. So as the groups become, of course, many, we shall also be in a position now to be charging those to join the group. So please use the opportunity when it is still there. Now, let us look at the instructions to candidates. This paper was taking 3 hours. And it is always a good and important idea to look at the instructions before you start attempting any of the items. So please, the first thing to do is to look at the instructions. So our instructions are as follows. The examination paper consists of 2 sections, A and B. It has 5 examination items. Then section A consists of 1 compulsory item, and as I have already said in my videos, this item comes from geometry. And I hope you know all the parts, all the topics of the construct that is called geometry. In case you have not got details about these sections, I will also attach the link to the video so you can go through and know what is really needed for needed from you whenever you are attempting some of these sections. Section B has two parts, part 1 and part 2, each with 2 optional items. And you are supposed to respond to only 2 items from section B, choosing 1 item from each of the parts 1 and 2. So in total, you are supposed to respond to 3 items. And don't make a mistake and you respond to more than the required items, because the item that will be the additional item will not be scored. So begin each item on a fresh page. All necessary working must be clearly shown. Graph paper is provided in case it is needed. Silent non-programmable scientific calculators and mathematical tables with a list of formulae may be used. Those are the instructions. For our case today, we shall be able to look at all the items in this paper. We begin by looking at item number 1. Item 1 says, a district survey team is designing a smart transport and communication layout for a new industrial park. The district survey office or is used as the reference point, with eastings and northings measured in kilometers. A service post P is located 3 kilometers east and 2 kilometers north of O, while another post Q is located 11 kilometers east and 8 kilometers north of O. The team wants to know the distance between points P and Q and are still challenged. Next, an old drainage boundary follows the straight line 2x minus 5y plus 4 equaling to 0. For emergency movement, the engineers want to construct a new access road through P perpendicular to this drainage boundary and determine where the two routes meet, but they are finding it challenging. Above the same industrial park, a drone signal platform is to pass through 3 aerial beacons A, B, and C, where the coordinates are measured in kilometers, and a drone flight corridor passes through the points R and S. The engineers need to determine where this flight code intersects the signal platform and whether the angle between the corridor and the platform is greater than certain degrees for stable signal transmission, but they are still challenged. On the ground design map, a landscape, a security boundary is modeled by the ellipse, whose parametric equations are x is equal to this and y is equal to that. A straight inspection path is planned along the line this. The planners want to determine the patrol positions where this inspection path cuts the elliptical boundary before approving the route, but they are still finding it difficult. Task: help the district survey team to overcome the challenges being illustrated in this scenario. So now let us look at how best we can help the survey team to overcome the challenges being illustrated. So what are the challenges? We shall begin by looking at this part. A district survey team is designing a smart transport and communication layout for a new industrial park. The district survey office or is used as the refer with eastings and northings measured. A service post P is located 3 kilometers east and 2 kilometers north of O, while another post Q is located 11 kilometers east, 8 kilometers north. So the team wants to know the distance between P and Q and are still challenging. So we shall look at this as the first part. As our first part, that is what we need to overcome first, this part here. So let us look at how best we can respond to that. So we are looking at a Kamasa mock examinations. So item 1 response, part A, we need the distance between the service posts P and Q. Let us try to interpret this question. The question is saying, or the scenario states that the survey office O is the reference point. Eastings mathematically will be representing the x coordinates. Then the northings will be representing the y coordinates. So when they talk about easting, that is an x coordinate, and the northing, that is a y coordinate. Okay, so what will that one mean? It means since we are told the service post P is located 3 kilometers east and 2 kilometers north, then it means post P has the coordinate 3 and 2. This is represented by easting and this is represented by northing. Then post Q has coordinate. Post Q is 11 kilometers east and 8 kilometers north of O. So it means post Q has coordinates 11 and 8. Now, there is a phrase which says determine the distance between points. They need to determine the distance between points P and Q. So when we look at this, the team wants to know the distance between points P and Q and are still challenged. So that tells you that you need to obtain the distance between P and Q, where P is this and Q is this. And how do you get that? We shall look at the required solution. So basically here, they are trying to assess the coordinates in the Cartesian plane if you know the distance between 2 points. And basically, they are looking at if you can be in position to interpret the real life coordinates. So we shall look at the required solution. So the distance between 2 points, if you have 2 points, x1, y1 and x2, y2, the distance between them is given by x2 minus x1 squared plus y2 minus y1 squared, everything under square root. So since we have 2 points, P and Q, so this can be our x1, this can be our y1. This can be our x2, this can be y2. So x2 minus x1, 11 minus 3 squared, plus y2, 8 minus 2 squared. So that will give us 8 squared plus 6 squared. And this will give us the distance PQ to be 10 kilometers. So clearly the distance between the two service posts is 10 kilometers. That is what we needed. We are given that the northings and the eastings are in kilometers, so that's why we are giving our distance in kilometers. So generally, we shall be able to have the distance between the two service posts as 10 kilometers. And we shall give the conclusion that hence the survey team should record that service post P is 10 kilometers from service post Q. So that is the required response to our first part. The next part, the next part is this. The team wants to know the distance. That is completed. Now, an old drainage boundary follows the straight line this. For emergency movement, the engineers want to construct a new access road through P. Through P, perpendicular to this drainage boundary. Remember, this is the drainage boundary. So the new access road passes through P, and we already know P. Passes through P and is perpendicular to this. Now they want to determine where the two routes meet, but they are finding it challenging. So we shall be looking at this as our next part of our task. So let us look at that. For our part B, we need to construct the access road through P that is perpendicular to the drainage boundary and determine where the two routes meet. So basically, we need to look at the question interpretation. So they are telling us that the drainage boundary is represented by 2x minus 5y plus 4, 2x minus 5y plus 4 equaling to 0. Now, the engineers want a new access road that one passes through point P. Point P is 3, 2. We already have that. Point P is 3 and 2. So it passes through point P, which is 3, 2, and is perpendicular to the drainage boundary, which is given by this. This is the drainage boundary. So the phrase perpendicular to this drainage boundary means that we must, one, find the gradient of the given line, the boundary line, which is this. Then find the gradient of a perpendicular line. Then after we form the equation of the required road through P, and after we determine the point where the two lines intersect from. So this is a problem involving equations of straight lines, and which I believe at the moment everyone knows. So what are some of the concepts that are assessed here? They want to look at, the examiners want to look at, are you able to convert a line and get the gradient? Are you able to look at the perpendicular gradients? Are you able to deal with the equation of the line through a point? And are you able to solve simultaneous equations for the linear equations? That is basically the mathematical concepts that are assessed in this part here. So let us look at what is the required response. So now let us first of all determine the gradient of the drainage boundary. So we shall try to rewrite this into the form which is y is equal to mx plus c. So in other words, we need to make y the subject. So first take these ones the other side, take this the other side, take this the other side. So you will remain with negative 5y, which is equal to negative 2x minus 4. So divide through by negative 5, and you should be able to get this. Now this is in the form of y is equal to mx plus c. So that means that your gradient for this line here will be 2 divided by 5. But now, since we are told that the line that is passing through P is perpendicular to this line here, and this line has got a gradient m1, which is 2 over 5, then we shall now determine the gradient of the perpendicular road. So for perpendicular lines, m1 times m2 is equal to negative 1. So meaning that you will substitute your m1 as 2 over 5, and you'll be able to get m2 as negative 5 over 2. So that will be the gradient of the required access rod. Now we are told that the access rod passes through the point which is 3, 2. So we need to get the equation of the line with gradient negative 5 over 2 and it is passing through at the point 3 and 2. So how do you get that? You know that m is same as y minus y1 upon x minus x1. So where x and y are the general points on this line. Now for this case, it means y minus y1 is equal to m into x minus x1. So our x1, y1 will be represented by 3, 2. Our gradient will be represented by negative 5 over 2. So substituting here into this equation, you will have y minus 2 is equal to negative 5 over 2 into x minus 3. So when you multiply by 2 this side, you'll get 2y minus 4 is equal to negative 5x plus 15. So try to rearrange it, and you'll be able to get 5x plus 2y minus 19 equaling to 0. So this will be the equation of the required access rod. But when you look at what we majorly need, we need to determine where the two roots meet. We need to determine where the two roots meet. So we have this root and the access root that we have simply obtained. So we need to see where do the two meet. So where the two meet will actually be at the point of intersection between the two lines. So we had the first one, which was given as 2x minus 5y plus 4 equaling to 0. Now we have this one. So we need the point of intersection. Which point of intersection is same as solving these two equations simultaneously, which I believe you know how to do that. So if you have these equations, you have 2x minus 5y equaling to negative 4. You have 5x plus 2y equaling to 19. I hope you should be able to deal with the solving of these equations. So when you solve these equations using either substitution method or elimination method, then you should be able to get the values for x and y as x equaling to 2 and x equaling to 3 and y equaling to 2. So solve these two equations here and obtain the values for x and y. So after getting the value of x as 3 and the value of y as 2, then you should be able to say that the two lines meet at the point which is given by 3 and 2. So in conclusion, we shall be able to say that the required access rod has this equation and it meets the drainage boundary at this given point. So in conclusion, we shall therefore say the engineers should construct the new access rod along this line, and the rod joins the drainage boundary exact at the service point, which is P, which is 3 and 2. Okay, so you realize that this point is 3, 2, and from the given information, P was also 3 and 2. P was also 3 and 2. So it implies that the engineer should construct the new access rod along this, and the rod joins the drainage boundary exact at this service post. So what do the examiners exactly expect from this question? So for you to be able to get a high score, then a high scoring response should, 1, identify the coordinates collected from the scenario, convert the line to gradient form, use the negative reciprocal for perpendicular gradients, should be in position to form the equation using the given point. You should be able to solve the two equations accurately and state the answer in the context of the industrial park. So basically, students who only write this without explaining what it is, that it is the meeting point of the access rod and the drainage boundary, may lose the communication marks, and this the competence-based assessment. Remember, communication is very important. Communication is very important. So that is all about this part here. So we shall now come to the next part. So we are trying to put these different parts separately, so we can easily answer them. So we can have this as our part C. So you see the task is a broad task, but this can be divided into different parts, so you can easily answer that. So for the next part, we shall be looking at this. Above the same industrial park, a drone signal platform is to pass through 3 aerial beacons. We have A, we have B, we have C. Where the coordinates are measured in kilometers, and a drawn freight corridor passes through the points R and S. So the engineers need to determine where this freight corridor intersects the signal platform and whether the angle between the corridor and the platform is greater than 30 degrees for stable signal transmission. But they are still challenged. So now we have to look at this part. We as well answer it. So that is like our part C. So basically from the given information, the scenario describes a drone signal platform which is passing through 3 aerial beacons, where we have A, which is 1, 1, 2, we have B, 2, 3, 5, we have C, negative 2, 2, and 7. Then we are told this is for a drone signal platform. Then a drone flight corridor passes through R and S. R, which is 3, 2, 3, S, which is 1, 1, 4. So the engineers need to determine where the flight corridor intersects the signal platform. So we need the intersection between this and this. So here the phrase signal platform platform passes through 3 points. This indicates that the platform is a plane in a 3-dimensional space. Now to solve this problem, we shall need to 1, determine the equation of the plane that is containing points A, B, and C. Then 2, we determine the equation of the flight corridor that is passing through R and S. And 3, we find the point that satisfies both equations, and that will be the point of intersection. So generally, this problem is involving about 3 things: vectors, planes, and lines in 3-dimensional space. So what are some of the concepts that are assessed here? So this part tests the ability to 1, form vectors between points in space. If you are able to find a normal vector to a plane using the cross product, if you are able to determine the equation of the plane, if you are able to represent a line in a 3-dimensional space, and if you are able to find the intersection between a line and a plane. So let us see how we can respond to this item. So we need to determine 2 vectors lying in the signal platform, because the plane contains the points A, B, and C. So what we shall do is let us get 2 vectors in the plane. So 2 vectors in the plane can be obtained from point A. So point A will be like our reference point. So we shall get point A as our reference point. So we shall need to get vector AB, because we need to get 2 vectors lying on this plane. So the 2 vectors lying on this plane can be easily obtained by considering one of the points to be your reference point. So we are saying 2 vectors in the plane can be obtained from point A, and we are having AB first. So let us get AB. AB is same as OB minus OA. So your OA is this, your OB is that. So when you get OB minus OA, you'll be able to get, so you are having OB minus OA. So you can deal with that in the coordinate form or else in the column form. So you are having 2, 3, and 5. You are subtracting 1, 1, and 2. So this should be able to give you 1, 2, and 3. So that will be a vector AB. Then get vector AC. A vector AC is same as OC minus OA. So you had OC, you had OA. So your OC was given as negative 2, 2, and 7. Your OA was given as 1, 1, and 2. So this would be able to give us negative 3, 1, and 5. So this would be our AC. So after obtaining the 2 vectors in the plane AB and AC, then the next thing will be to determine the normal vector to the plane. And how do we get the normal vector to the plane? A normal vector is perpendicular to every vector lying in this plane. So what we shall do, we shall get AB cross AC. So how do we get AB cross AC? AB cross AC. So we already have our AB here, 1, 2, 3. We already have our AC, negative 3, 1, and 5. So we shall use cross product, and the cross product, as we know, is similar to using the determinant method. So how shall we deal with that? So to use the determinant method, you will be crossing out this and this, then you take the determinant of the remaining one. So in other words, you will take the determinant of that, and you will have this is I into, so this will be the determinant of 2, 3, 1, and 5 into I minus, then next you will cross out the first row and this one here. So when you cross out this and this, what remains? You remain with 1, 3, negative 3, and 5 into J. Then we shall add there. The next thing we shall do, we shall now eliminate this and this. So what remains is 1, 2, negative 3, and 1 into vector k. So what will this one give us? This will be 10. Let's get the determinant of a 2 by 2. This is 10 minus 3 into 10 minus 3 into I minus, this is 5 minus minus 9 into j. This is 1 minus minus 6 into k. So basically, we shall be able to get 10 minus 3. This will be 5 plus 9. This will be 1 plus 6. So you'll be able to get a 7, negative 14, and a 7, which you can easily simplify, because this can be written as 7 into 1, negative 2, and 1. So you take the simplified expression, and with there we shall be able to use our normal n as 1, negative 2, and 1. So we shall now have our normal vector. So we have obtained the normal vector to the plane. Now, after getting the normal vector to the plane, we can get the equation of the plane. And the equation of the plane will, of course, become the equation of the signal platform. So, what will be the equation of the plane? The equation of the plane is same as n dot r, which is equal to n dot a. A is our reference point, which we are using. N is what we have obtained here. R represents the general point on this plane. So this can be written as, we already have our normal, so that is 1, negative 2, and 1, and this is into x, y, and z, which is equal to n, that is 1, negative 2, and 1, into a. Our a is 1, 1, and 2. So when you simplify that, of course you are dotting here, this is dot, so this will be x minus 2y plus z, which is equal to 1 times 1, that is 1, minus 2 plus 2. So we shall have x minus 2y plus z, which is equal to 1. So it means the equation of the plane will be x minus 2y plus z minus 1, which is equal to 0. So this will be the equation of the plane. So the equation of the plane is x minus 2y plus z minus 1. Or else you can simply use this similar way we have done it here. That is n dot, then you get x minus your reference point. So that is x minus 1, y minus 1, z minus 2. Simplified, and also you'll be able to get the same equation of the plane. So this will be the equation of the signal platform. Now, we have obtained the equation of the signal platform. Remember, the question wants us to determine where this flight corridor intersects with the signal platform. So we have got the equation of the flight corridor. We have got the equation. Okay, this is the equation of the signal platform. Now we need to determine the equation of this line here, which is joining R and S. So next, let us determine the equation of the drawn flight corridor. So the flight corridor passes through this point and this. So what we shall do as well is to obtain the direction vector. So since we have these 2 points, we shall obtain the equation of the line that is passing through these 2 points. As we know, the equation of the line is given by R, which is equal to like A plus lambda vector D. Okay. So for our case, the lambda, we shall use the scalar t. We shall use the scalar t. Now, we have our point A will be like this point R. So in other words, this R will be the general point. The D will be the direction vector. So the direction vector D will be same as RS. So get RS. RS is given by this. So we are getting RS as negative 2, negative 1, and 1. So this will be D. Now, after getting this D here, after getting this D, which is the direction vector, now you can get the equation of the line. So it means we shall have x, y, and z, which is equal to, we shall use R as our the point through which the line is passing, 3, 2, and 3. And this, we add there t into the direction vector, negative 2, negative 1, and 1. So from here, we shall be able to get x as 3 minus 2t. We shall be able to get y as 2 minus t. We shall be able to get z as 3 plus t. So we shall be able to get these parametric equations of the line. And that line is what we call the flight corridor. But now we need the intersection point between this line, this one here, and this plane. So how do you get that? The point of intersection must satisfy the two equations. So that's why we shall get x, we substitute it in the equation here, we place y, we place z, and get the value of t. Now from here we are saying the intersection point must satisfy the equation of the plane. So it means x minus 2y plus z minus 1 equaling to 0 must be satisfied by these equations. So for that case, where there is x, put there 3 minus 2t, where there is y, 2 minus t, where there is z, 3 plus t, then minus 1 equaling to 0. Simplify that and get the value of t. So when you simplify that, you should be able to get the value of t as -1. So after getting the value of t as -1, now go on and get the value of x, the value of y, and the value of z by substituting them back in, by substituting t back in these equations. So where there is t, put there -1. So it means you will have like your x as 3 minus 2 into -1, y as 2 minus -1, z as 3 plus -1. So basically, you'll be able to get 5, you'll be able to get 3, you'll be able to get 2. So the point of intersection will be 5, 2, and 3. So the drone flight corridor intersects the signal platform at 5, 3, 2. So therefore, the engineers should locate the meeting point of the drone corridor and the signal platform at coordinates 5 kilometers east, 3 kilometers north, and 2 kilometers above the reference level. So that will be the conclusion for that part. Okay, so they are saying the engineers need to determine where the flight corridor intersects, that we have obtained, then whether the angle between the corridor and the platform is greater than 30 degrees. So let us look at the angle. So we have got, or we have already got the equations for the two, that is the flight corridor and the signal platform. So we have already got the equations representing that. So now we need to determine the angle between the drone corridor and the signal platform and see whether this angle will be greater than 30 degrees. So what we need to do is to simply identify what we call the d, that is the direction vector, and what we call the normal vector, because we have the line represented by this equation. We have the signal platform represented by this, and we need the angle between the two. So in other words, you need the angle between the plane and the line. So how do we get the angle between the plane and the line? So one, we shall say the drone flight corridor is represented by a line which has got this as the direction vector. The signal platform is represented by this plane. But we know that for the plane, it is always in the form of ax plus by plus cz plus k equaling to 0, where this a, b, and c represent the normal vector. So it means our normal vector is a, b, and c. So it means our normal vector will be 1, -2, and 1. Now the engineers want to know the angle between the line and the plane. So for a line and a plane, the angle is obtained directly by using this expression. So this is how we obtain the angle between the line and the plane. So the mathematical concepts that are assessed here is that this part is testing the learner's ability to identify the normal vector of a plane, to identify the direction vector of a line, if you are able to apply the dot product, and if you are able to get the angle between a line and a plane. So that is basically what this part is testing. So what will be the solution? We are given them, we know the normal vector to the plane as this. The direction vector of the flight corridor is this. So we need to substitute in this. That is n dot d over magnitude of n times magnitude of d. So let us look at that. So what will be n dot n? N dot n, you are getting n, you are dotting it with d, which I hope you know how to do. So you are getting this. So n dot d is same as 1, -2, 1. You are dotting it with -2, -1, and 1. So dot that will be -2. This one will be +2, then +1, and this will give you 1. So magnitude of n dot d will be 1 still. Now next we need to find the magnitudes of each, magnitude of n and magnitude of d. So find the magnitude of n as that, then find the magnitude of d as that, then substitute in this expression. So this expression comes from n dot d is equal to magnitude of n, magnitude of d, and then sine of theta. But if you are interested in acute angle, then you can take the magnitude of that. So you can get an acute angle. So after getting magnitude of n and magnitude of d, you should be able to get sine of theta as 1/6, which will give us the value for theta as 9.59 degrees. So the value of theta will be approximately equal to 9.6 degrees. And in conclusion, we can say that the angle between the drone flight corridor and the signal platform is approximately 9.6 degrees. So since 9.6 degrees is less than 30 degrees, then it means the angle is not greater than 30 degrees. So therefore, the proposed drone flight corridor does not meet the required condition for stable signal transmission. That should be your conclusion. Please always give the conclusions. Communication is very important. So what are the examiner's observations? A common challenge in three-dimensional geometry is basically in identifying which angle is required. So learners should distinguish between, if you need the angle between two vectors, we simply use cos theta is equal to that. This is the angle between two vectors. You are looking at a plane and a plane, a line and a line, a vector with a vector. You use this expression, but the angle between a line and a plane is given by this. So the second formula is preferred here because the question asks directly for the angle between the corridor and the platform, and for which we're having the plane and the line. So these are some of the common mistakes students normally make. So using cosine rule, cosine instead of sine. Some runners write this and they get this as the angle. So this is incorrect because that angle is the angle between the line and the normal vector. That angle you are getting is the angle between the line and the normal vector. Now, the next one is forgetting that the coefficients of the plane equation form the normal vector. So when you forget that the coefficients 1, -2, 1, these ones form the normal vector, those are some of the challenges. You find someone is beginning by -2, then puts 1 and 1. Then another one is using the wrong direction vector for the line. So the corridor passes through this and this. So the direction vector can be obtained by getting s minus r, or you can also get r minus s. So both are acceptable because they represent the same line direction. So whether you have this or you have this, or you will get the correct answers. So that is all about our part, this part here that we are saying it is around part C, though this part we had also another part which was talking about the angle. So next we have the last part, and that is about this one here. So we have another part, that is the final part. So if you have watched up to this given point, please make sure you subscribe to TV Math. TV Math brings to you all that is necessary for you to pass mathematics. So if you are here for the first time and you haven't subscribed, please kindly subscribe to TV Math. There are very many videos that have been done for you to prepare you for your final examination. So simply go to TV Math, check for any of the videos that you are interested in. And I would wish to as well remind you that TV Math website is already here. So in case you are interested in resources, and you would like as well to get to master mathematics from anywhere, then please join the 500 plus students who have transformed their grades with personalized online tutoring. For free consultation, feel free to get to us, and we basically look at how best we can help you to pass mathematics. There are very many resources that have been uploaded on this website here. So here we have high quality materials that you might need for A-level, O-level, and university. For past papers, some are paid and others are free. And because majority needed these past papers, we have already formed a WhatsApp group. So if you are interested in joining this group, feel free to find the link in the description, or else contact me. I will be able to send you that link. There are also some of the materials, for example, A-level principal seminar items. If you need the items paper 1 and paper 2, over 30 items with solutions, please simply come to our website, and those items there are at a cost, a very small cost. You can easily get both papers, that is paper 1 and the paper 2 item bank. So please get the item bank and you pass mathematics with ease. Also, we have a joint mock with the full guide, that is a complete response for each of the items within this paper. So if you are also interested in these solutions, feel free to buy these now. So come to the option for buying, and you'll be able to be taken through the steps for you to buy some of these materials for your own use. So there are a lot of them. Scenario 5, midterm 2, complete paper with comprehensive responses. We also have them at a very small cost. So please, you can as well buy a complete bundle for all the items at a discounted price. That is everything that you need for your exam preparation. So you can buy a bundle at this small cost. So bundle would have gone to up to 33,000, but you can easily get it at 25,000. So we also have some of the sample papers and guides from UNEB. These are free of charge. You simply download any of these. Please, you can connect to us on our YouTube. You can connect to TV Mathab on WhatsApp channel, WhatsApp group, Facebook, Telegram. Any of these, you will be able to get to TV Mathab. So those who are interested in one-to-one tutoring, you can be a group and you try to raise some small money. You can as well be taken through our classes. So please, you can book the one-to-one tutoring now. You can join a group and as well book as a group. I will be able to handle you on time. So please, if you are interested in excelling in mathematics, come and visit our channel. Check for some of the required resources that you might need in preparations for your final examinations. Let us look at the last part. So they are saying, on the ground design map, a landscaped security boundary is modeled by the ellipse whose parametric equations are x equaling to 1 plus 5 cos theta and y is equal to this. A straight inspection path is planned along this line. The planners want to determine the patrol positions where this inspection path cuts the elliptical boundary before approving the route, but they are still finding it difficult. So that is the given information, and we would like to use this information to obtain the required response. So let us see what is required there. So that will be our part E. So we need to determine the patrol positions where the inspection path cuts the electrical security boundary. So what are we given? Let us look at the question interpretation. So the landscaped security boundary is represented by the parametric equations x equaling to 1 plus 5 cos theta and y equaling to negative 2 plus 3 sin theta. The inspection path is represented by this. Okay. The planners want to determine the positions where the inspection path intersects the elliptical boundary. Although the ellipse is given a parametric form, as we can see here, then the required answer is a set of coordinates. What we need is the coordinates, because we need to determine the patrol positions where the inspection path cuts this boundary. Okay, so although the ellipse is given in parametric form, the required answer is a set of coordinates. Therefore, we can first remove the parameter theta and obtain the Cartesian equation of the ellipse. So the problem then becomes finding the points of intersection. So in general, what we need is the points of intersection between the ellipse and the straight inspection path. So what we shall do here, before we look at the solution, the mathematical concepts assessed here is the one to test whether you are able to eliminate a parameter from parametric equations, whether you are able to obtain the Cartesian equation of an ellipse, whether you are able to solve simultaneous equations involving a curve and a straight line, and whether you are able to interpret intersection points in a real-life situation. So we shall begin by looking at the required response. So we shall look at elimination of the parameter theta first. So the parametric equations given are x equaling to that and y equaling to that. So from this, we shall make cos of theta the subject. So we first take this one the other side, then divide by 5. So cos theta will be x minus 1 divided by 5. Then sin theta will be y plus 2 divided by 3. Y plus 2 divided by 3. So we know if we want to eliminate cos and sine, we shall use the identity, that is the Pythagorean identity, which is sine squared plus cos squared is equal to 1. So we shall have to substitute for sine squared. Sine is y plus 2 divided by 3. Cos is x minus 1 divided by 5. So when you get this squared plus this squared, you should be able to get 1. So where there is sine and cos, we are putting these expressions. And this is the equation we shall have. Now, it means the Cartesian equation of the ellipse is x minus 1 squared divided by 25 and y plus 2 squared divided by 9. So you have split this, the numerator and the denominator. Okay, so x minus 1 over 25, this is squared. Okay, so we shall be able to get this. Now, they are telling us that that Cartesian equation, a straight inspection path is planned along this line, and we want to determine the position where the Cartesian equation meets this line. So we need the point of intersection between this and this. So to get that, we shall use the substitution method. So make y the subject here to become 3x plus 2 divided by 5, then come and substitute it here. That is what we shall do. So substitute the line equation into the ellipse equation. And when you do that, where there is y, put 3x plus 2 divided by 5. So we want first to look at what will be y plus 2. Y plus 2 is same as where there is y, put 3x plus 2 divided by 5. Add there 2. So we want first to get this first, where we are substituting y as this. So when you look at that, get to the LCM and simplify. So that will be plus 10 divided by 5. So you get 3x plus 12 divided by 5. So you can put a 3x out and you'll be able to get 3 into x plus 4 divided by 5. So in this equation where there is y plus 2, let us simply substitute there this. Where there is y plus 2, we are putting this. So that's why we are saying that this one here can be simplified. Because you have 3 into x plus 4 the whole of this squared, actually divided by 5, the whole of it squared, and again divided by 9. Okay, again divided by 9. So this is same as 9 into x plus 4, which is squared, divided by 25 times 1 over 9. So looking at that, you'll be able to get x plus 4 squared divided by 25. So here you still have x minus 1 squared over 25. So this is what you remain with when you multiply through by 25. So simplify this, simplify that, and you should be able to get the values of x as -4 and x as 1. So go on and get the corresponding values of y. Go on and get the corresponding values of y. So when we get the corresponding values of y by substituting in this equation of y is equal to 3x plus 2 over 5. So when you substitute into this, the value of x as 1, you should be able to get y as 1, which will give us the coordinate as 1, 1. When you substitute into x equaling to -4, you should be able to get -2, and that will give us the point as -4 and -2. So these are the points of intersection. Remember, the question wants us to determine the partial positions where this inspection path cuts the elliptical boundary before approving the route. So these are the positions, 1, 1 and -4, -2. Now, in conclusion, we shall say the inspection path cuts the elliptical security boundary at the two partial positions, that is 1, 1 and -4, -2. So therefore, the planners should mark these two coordinate positions as the locations where the inspection path crosses the security boundary. So what are some of the examiner's observations? So for questions involving parametric equations, learners should first identify what the question requires. In this case, the question asks for positions, meaning that the final answer must be coordinates, not values of the parameter, not the value of x and y. So here you actually have two possible methods you can use. One, the parametric method, where you can substitute the parametric equations into the line equation. Two, you can solve for theta. Three, you can substitute back to obtain the coordinates. That is the first method. That is for parametric method. Then two, you can use the elimination method, where you are strictly removing the value of theta. You obtain the Cartesian equation and you get the intersection between the curve and the line. So both methods are correct. However, the elimination method is recommended here because it directly produces the required coordinate positions and reduces the chances of errors in solving trig equations. So here are some of the common mistakes students normally make. One, forgetting to remove the parameter completely. Some learners find cos theta as x minus 1 over 5, sin theta as y plus 2 over 3, but they failed to use this identity to obtain the equation of the ellipse. So those are some of the common errors. So making errors when expanding brackets. Also, we have found many students who are expanding this as x squared. They are simply squaring x and 4. So they say x squared plus 4 squared, and they get x squared plus 16. That is wrong. You have to be careful there. So it should be x squared plus 8x plus 16. Another one is substituting incorrectly into the ellipse equation. A common error occurs when finding y plus 2, and students may write 3x plus 2 over 5, then plus 2, and they simply instead of writing this and simplify it, so they simply leave it here, and this becomes a bit challenging for the students if you don't simplify it. So the correct simplification should be having 3x, you get the LCM, and that would be easier. So next is giving all the values of x. So they, after reaching somewhere where we had our x values here, after getting x values, you stop there. You get x as 1, x as -4, and you stop there. That will be wrong. So you need to go on and get the corresponding values of y, and you should be able to relate the final answer to the scenario. So the final answer should be this. So a final answer such as this does not fully communicate the result. So a complete conclusion should state that the inspection path crosses the elliptical centroidal boundary at the patrol positions 1, 1 and -4, -2. So don't simply give this, what is this? So that will be the question, what is this? So you should be able to relate this with what you have been asked. So this is the final advice, especially on this item here. So this item demonstrates the type of integrated problem which is expected under our new curriculum. So the mathematics is presented through a practical situation, and learners must find it and identify the appropriate mathematical model before solving. So to perform this well, you should be able to read the scenario carefully before writing equations. Identify what the objects represent. Is it point? Is it a line? Is it a plane? Is it a curve? Or the intersections? Then you need also to translate some words into mathematical conditions. When they say distance between posts, so there you need to be knowing that you are looking at the distance formula. Perpendicular road, that is gradient whose product is -1. Platforms through 3 points, equation of the plane. Flight corridor intersects this, you are looking at the point of intersection. Inspection path cuts this, you are looking at the intersection of curves. So you should be able to show the method clearly. Even when the final answer is incorrect, the correct approach may earn you some method marks. Then always conclude in context. The final statement should explain what the mathematical result means for the engineers, for the surveyors or planners in the scenario. Then finally, check your answer. Ask yourself, does the answer satisfy the original equations? Are the units included? Have I answered the exact task given? So majorly, a strong response to a competence-based mathematics question follows this pattern. Interpret the scenario, create the mathematical model, solve, and then interpret the result. So this approach enables learners to handle unfamiliar real-life applications of mathematics confidently. So please, that is all that we can say about our item number 1 for Kamasa mock. If you have reached up to this given point, please don't forget to subscribe to TV Math, and don't forget to visit our channel so you can get a lot of information about TV Math. If you want to join our community, if you want to join our WhatsApp channel, you can easily come to this and it will take you directly to the channel. You can join our WhatsApp group, you can join us on YouTube, you can join our Telegram to get notes. You can as well directly message me on Facebook as well. So you will be able to find a lot about TV Math, a lot of resources. You need papers, you need some consultation, then please come to website, book with TV Math. Let us look at item number 2. Let us now talk about item number 2. Item 2 comes from section B, part 1, and this part 1 consists of 2 items, that is item 2 and item 3, from the construct that we call algebra. We already talked about the structure of these papers here. So in case you have not watched the video about the structure of mathematics, that is principal mathematics paper 1 and paper 2, the different sections, with different constructs, and also under these constructs here, we also talked about the topics that constitute those constructs. So under algebra, we have got topics that are set under algebra. Under geometry, we talked about the topics under that, and calculus, you must be knowing these topics by the time you enter into the examination. So in case you missed that video, I will put it in the description for this same video, so you can go through it and you get to know which topics make up algebra, which topics make up calculus, and which topics make up what we call geometry, and also the details about principal mathematics paper 2. So item 2 says the formula of producing a certain bread of product in a factory follows the polynomial p of x, which is equal to that. The formula was kept with unknowns a and b for security purposes. However, to describe the value of a and b, it is true that p of x leaves a remainder of 16 when divided by x minus 1, and a remainder of 46 when divided by x minus 2. The factory manager needs to use the model, but is unable to determine the values of a and b. The factory manufactures a product whose expiry time follows the equation which is given as this, where x is the number of years representing the expiry time. The factory manager wants to determine the expiry time for the product in order to plan accordingly. During the festive season, James, Peter, and Mary visited the factory and purchased 3 kinds of products from the factory. James bought 3 kilograms of kind A, 5 kilograms of kind B, and 6 kilograms of kind C, and paid Ugandan shillings this. Peter bought 53 kilograms of kind A, 30 kilograms of kind B, and 19 kilograms of kind C, and paid this amount. Mary bought 9 kilograms of kind A, 12 kilograms of kind B, and 5 kilograms of kind C, and paid this amount. So the factory manager is interested in finding out the price at which each kind is being sold by his workers for proper accountability. So help the factory manager to solve the challenges as illustrated in the scenario. So that is our item. That is our item number 2. So item number 2 is given as that, and from that we need to help the manager to solve his challenges as illustrated in the scenario. So we shall begin by trying to divide the scenario into different parts, and we answer them accordingly. So for item 2, we shall try to have this one as our first part. So this will be our first part. So this part here, they are telling us that the formula of producing a certain brand of product in a factory follows this polynomial p of x, which is equal to this. The formula was kept with unknowns a and b for security purposes. However, to describe the value of a and b, it is true that p of x leaves a remainder of 16 when divided by x minus 1, and a remainder of 46 when divided by x minus 2. So the factory manager needs to use the model, but is unable to determine the values of a and b. So what we need to do is to help the manager in determining the values of a and b. So that is what we need to look at. So let us see how best we can respond to that. Okay, so let us look at the required response. So we are looking at item 2, response. So the first part is to determine the values of a and b. So we are told that the polynomial is given as p of x, which is equal to ax squared plus 3x plus b. The important point is that when a polynomial p of x is divided by x minus c, then the remainder is p of c. You must recall that from the remainder theorem. When you have a polynomial p of x and is divided by x minus c, then we represent the remainder to be p of c. So that is what we can recall from what we call the remainder theorem. Now we are told that the polynomial p of x is divided by x minus 1, and it leaves a remainder of 16. So what does that one mean? It means that when you set this x minus 1 to 0, you get your x as 1. So p of 1 is equal to 16. So this is the remainder. But what is p of 1? Remember, we are given p of x as ax squared plus bx, plus 3x plus 3x plus b. So we want P of 1. P of 1 is same as A into 1, where there is X put 1. 3 into 1 plus B. But P of 1 is 16. So that is what we shall have here. So this will give us A plus 3 plus B is equal to 16, meaning that A plus B will be equal to 13. And this will be equation number 1. Next, they are telling us that when the polynomial P of X is divided by X minus 2, the remainder is 46. So meaning P of 2 is equal to 46. So substitute in your expression for P of X, put there 2. When you put there 2, then you will have A into 2 squared plus 3 into 2 plus B equaling to 46, meaning that 4A plus 6 plus B will be equal to 46. 4A plus B will be equal to 40, and this will be equation number 2. So solve the two equations, equation 1 and equation 2, simultaneously and get the value for A and B. So you have 4A plus B equaling to 40. You have A plus B equaling to 13. So you can easily eliminate B. You get 3A, which is equal to 40 minus 13, which is 27. So divide by 3 on both sides, and your A will be equal to 9. So if A is 9, then you can say from A plus B equaling to 13. So your A will be 13 minus 9, and A becomes 4. So you will be able to get the value of A, you'll be able to get the value of B. So the formula will therefore become P of X equaling to 9x squared plus 3x plus 4. So it means remember, the factory manager needs to use the model, but is unable to determine the values of A and B. So you are able to get the values of A and B, and now this will become the model. So it means the factory manager can use the model which is given by this one here. So you can give that as the conclusion. So you can say the factory manager can use the model P of X, which is equal to 9x squared plus 3x then plus 4. So you have substituted for values of A and B. So that would be our first part. Then the next part that we need to look at, the next part is saying the factory. So this will be our next part. The factory manufactures a product whose expiry time follows the equation, this one here, 3 to the power of 2x plus 1 plus 3, which is equal to 10 into 3 to the power of x, where x is the number of years representing the expiry time. So the factory manager wants to know the expiry time for the product in order to plan accordingly. So this is now the part that we shall look at. So part that we are calling part B is finding the expiry time of the product. So the expiry time follows this. So important point here is that the expression contains 3 to the power of 2x. So we introduce the substitution. So what we shall do here is to try to manipulate this. So when you try to manipulate this, this will be 3 to the power of 2x times 3 to the power of 1 plus 3, which is equal to 10 times 3 to the power of x. So this will be 3 to the power of x, and again this is squared. We want to try to create this one here. So you multiply by 3 plus 3, which is equal to 10 times 3 to the power of x. So you can let your y to be 3 to the power of x, and that means this will give us y squared times 3 plus 3, which is equal to 10 times y. So 3y squared minus 10y plus 3 will be equal to 0. So that will be the equation that we can form, and from this equation we can try to solve this equation. I hope at the moment everyone knows how to solve such quadratic equation. So that one can be easily solved, and you get the values for y as a third and y equaling to 3. So since y is equal to 3 to the power of x, then it means for the first case we shall have 3 to the power of x equaling to a third, because y is a third, which will give us 3 to the power of x, which is equal to 3 to the power negative 1, and that means that the value of x will be negative 1. So that is the first case. The second case, y is equal to 3, so 3 to the power x is equal to 3, and the 3 is same as 3 to the power 1, giving us x as 1. Now, since expiry time represents the number of years, then the valid value will be x equaling to 1, not x equaling to negative 1, because we are looking at the number of years. So if x represents the number of years, then of course shall not have the negative year. So it means the product expires after 1 year. So this will be the expiry time for the expiry time for the product. So the expiry time for the product is exactly after 1 year. And that part will also be answered. So this is our part 2. This is our part 2, or what we are calling part B. Then the next one, we are having this information that will be our part 3. So that will be our part 3. So from that, so we need to determine the selling price of each of the products, because we are told that during the festival season, James, Peter, and Mary visited the factory and purchased 3 kinds of products from the factory. James bought 3 kgs of kind A, 5 kgs of kind B, and 6 kgs of kind C at this cost. So looking at what we are given, we don't know the cost of each kilogram of each kind of the products. So what we can do is we can rate the prices per kilogram of products A, B, and C to be X, Y, and Z. So if that is the case, then looking at what James bought 3 kilograms of kind A. Remember, each kilogram of kind A is at X shillings. So that will be 3 times X, 5 times Y, 6 times Z, giving us the total of this. So that will be the first equation. So in the equation for Peter, then you look at for Peter, that is 53 X, 30Y, 19Z, equaling to this cost, and that will give us equation number 3. Then you look at Mary, do the same. So Mary bought 9 kilograms of kind A, 12 kilograms of kind B, and 5 kgs of kind C, paying this amount. So do the same for Mary, then have these equations. So these will be the 3 equations that we shall have. So solve these equations simultaneously, and you should be able to solve these equations and get the values of A. You should be able to get the values of X, Y, and Z. So from there, you will be able to get Z as that. You will be able to get Y as this. You will be able to get your X as this. Remember, X was the cost for A, Y was the cost for B, and Z was the cost for C. So from there, we shall be able to get the cost of buying each kilogram for kind A, B, and C. So from there, we shall be able to have kind A, each kilogram at 45,000, kind B at 18,000, and kind C at 30,000. So I hope everyone at the moment at least knows how to solve 3 simultaneous equations. And in case you don't know this, please make sure you try as much as possible to know how to solve these equations. But I believe everyone at the moment knows how to do that. So solving those equations, you should be able to get the answers, and those are the prices for A, B, and C. So what will be the interpretation? The factory manager should set the selling prices as kind A should be that, kind B should be that, and kind C should be that. So these values help the manager to monitor the sales and improve accountability among workers. And that will be the end of item number 2. So looking at what we have done in item number 2, in case you have any questions regarding what we have so far looked at, please feel free to put it in the comment section, and I will be able to address it. Otherwise, if you are here for the first time, please TV Mathab Educational Consultants are here to support your excellence in mathematics education. We provide services such as one-to-one online learning in mathematics, customized examination papers, and marking guides for schools, especially for O-level, A-level, A-level subsidiary mathematics, university mathematics courses, mock examinations, continuous assessment tests, or revision packages. If you are interested in video lessons and examination preparation support, feel free to contact me at this number. You can as well visit our YouTube channel, TV Mathab, for free mathematics video lessons. So for further details, those that use WhatsApp, you can contact me using this MTN number or Airtel number. All these numbers are on WhatsApp. So please contact me in case you have any challenges, in case you would like to join a WhatsApp group. So please make sure you contact us as early as possible before the group is full. So TV Math is here to ensure that you are empowered. You are empowered in mathematics. So we shall be looking at our next item, and that will be item number 3. We shall now look at item number 3. As we said, item 3 also comes from the construct. Item 3 says, one of your relatives owns a grain milling business. While reviewing the monthly sales records, he found that two quantities X and Y, representing the number of flour sacks delivered to two different distribution centers, satisfy the conditions. We have log 10 of X minus log 10 of Y is equal to 1.0, and log 10 of X plus log 10 of Y is equal to this. He wants to determine the exact number of sacks supplied to each center and requests for your help. 2. We are also told he also uses the expression x plus 3 over x minus 1 to model the efficiency ratio of one of the milling machines. For the machines to operate safely, the ratio must remain greater than 2. He therefore needs to determine all possible values of x that satisfies this condition, and he requests for your help. Next, we are given that during the maintenance inspection, the technician obtained the quadratic equation given as this, whose roots are alpha and beta. After modifying the machine settings, he was advised to use a new equation whose roots are alpha to power 3 and beta to power 3, but he is finding it difficult. In the accounts office, one of the accountants is estimating the cost of fuel used by the milling generators using the expression 2 minus x to the power of 6. He requires the first 3 terms of its expansion in order to estimate the value of this, but he is unable to do it. Help your relative to overcome his challenges and give the necessary judgment where possible. So that is the information or the scenario that we are given, and from that we need to look at the required responses. So let us look at the required responses. So we shall begin by looking at the first part. So we are told that one of your relatives owns a grain milling business. While reviewing the monthly sales records, he found that two quantities X and Y, representing the number of flour sacks delivered to two different distribution centers, satisfy this equation and this. That is what we are given. Then he wants to determine the exact number. He wants to determine the exact number of sacks supplied to each center and requests for your help. So we shall first of all look at this. This will be like our first part. This will be like our first part. Then we need to look at the required response. So we need to determine the number of flour sacks supplied to each distribution center. What are we given? We are given that the number of flour sacks delivered to two different distribution centers satisfy log 10 of x minus log 10 of y equaling to 1, and log 10 of x plus log 10 of y equaling to log 10 of 2.5. So we know from the rows of logarithms, if you are subtracting, it is same as dividing here. So if you have log of a minus log of b, of course that is log 10. If you have log 10 of a minus log 10 of b, this is same as log 10 of a divided by b. So it means if we have log 10 of x minus log 10 of y equaling to 1, we can say this will be log of x, log 10, this is log 10 of x divided by y, which is equal to 1. And you should as well recall that if you have log a of b equaling to c, then in index form, b will be equal to a to the power of c. b will be a to the power of c. So what does that one mean? This means that if I have log 10 of x divided by y equaling to 1, it means that x divided by y is 10 to the power of 1, meaning that x over y is equal to 10, and this implies that x is equal to 10y. So that is what we shall be having here. Now, after obtaining that, next, if you are having log 10 of x plus log 10 of y equaling to log 10 of 2.5, this will also be the same as having log of a, log 10 of a plus log 10 of b is same as having log 10 of a times b. So for that case, it means this will give us this expression here, this one here, will give us this. Will give us log 10 of xy is equal to log 10 of that. Is equal to log 10 of that. Now, from there, since this is log 10, this is log 10, then we can say xy is equal to 2.5. Now, from there, we have xy equaling to 2.5, and we had that x is equal to 10y. Now, what we shall do is we shall solve the two equations simultaneously. So, since x is equal to 10y, we shall substitute x equaling to 10y into this equation, and this will give us where there is x, put 10y. So, it will be x, that is 10y times y, is equal to 2.5. So 10y squared is equal to 2.5, and y squared will be equal to 0.25. But since logarithms are only defined for positive numbers, then we shall be taking y as that, because when you look at y squared is equal to 0.25, so y will be the square root of 0.25, and the square root of a number is a plus or a minus. So it means this would be giving us y as plus or minus 0.5. But because logarithms are defined only for positive numbers, and we cannot have log 10 of a negative value, so it means we shall only take the value of y to be y equaling to 0.5. So that would be the value of y. So after getting the value of y, we shall get the value of x, because x is same as 10y, so it will be 10 times 0.5, which will give us 5. So the x value will be 5, and the y value will be 0.5. So what does that one mean? Remember, by the equation, they are saying, while reviewing the monthly sales records, he found that two quantities, that is x and y, represent the number of sacks delivered to two different distribution centers. So what does that one mean? It means the first distribution center received 5 sacks, while the second received 0.5 sacks, or its equivalent quantity. So these values satisfy both logarithmic conditions. So that will be the required judgment. So next we shall look at the next part. The next part says that he also uses the expression, that is x plus 3 divided by x minus 1, to model the efficiency ratio of one of the milling machines. So for the machine to operate safely, the ratio must remain greater than 2. He therefore needs to determine all possible values of x that satisfy this condition, and he requests your help. So this will be like our second part. So let us look at that. He also uses this expression. To model the efficiency ratio of one of the milling machines. And for the machine to operate safely, the ratio must remain greater than 2. So looking at the required solution, so we are given the ratio must remain greater than 2. So meaning x plus 3 over x minus 1 should be greater than 2. So what we shall do here, bring all the terms on one side. Please don't reach here and you simply cross multiply. That will give you a wrong answer. So what we shall do, bring this one on the other side, then get the LCM. So LCM will be x minus 1, like the way we have it. So we have x plus 3 minus 2 into x minus 1. So looking at that, it will give us x plus 3 minus 2x, then plus 2. So this will be 5 minus x. This will be 5 minus x divided by x minus 1, which is greater than 0. So when you divide this, or you multiply through by -1, when you multiply through by -1, so because this one here can be written as negative of x minus 5 over x minus 1, this is greater than 0. So I can write this as x minus 5 over x minus 1. When I divide it through by negative, this will be less than 0. Recall that when you divide by a negative value, then this one must change the sign. So from here we can determine the critical values. So we shall have x equaling to 1 and x equaling to 5. So equate each of these. That is x minus 5 to 0, x minus 1 to 0, and get the critical value. So the critical values will be x equaling to 1 and x equaling to 5. So from there, we can look at the sign change in different intervals. So for x for x less than 1, so what will be the sign change of x minus 5? So here you will have your x minus 5. So here you have your x minus 1, and here you have the fraction that is x minus 5 divided by x minus 1. So when you consider for x less than 1, you can take a value like x less than 1, like a 0. So this will be a minus. When you put a 0 here, it will be a minus. So the fraction, it is a minus divided by minus, which will give us a positive. So do the same, pick a value between 1 and 5, that is like 2. This will be a minus, this will be a positive. When I get minus divided by positive, I will get a minus. So do the same, pick a number like 6. So this is positive, this will be positive, this will be positive. So we need where our expression is less than 0. So the expression will be less than 0 in this given range. So x is less than 0 here. That is in the range 1 less x less 5. So it means the expression will be less than 0, because this is what we are basing on, and this fraction is this one here. So it means the answer will be the region which is between 1 to 5. So we shall be able to say that the milling machine operates safely only when 1 is less than x and is less than 5. And the values x equaling to 1 will give undefined expression, and x equaling to 5 will give the ratio equaling to 2. All these values, x equaling to 1 and x equaling to 5, are excluded, so they are not part of this range. So that's why we are saying the milling machine operates safely only when 1 is less than x is less than 5, and that will be the required answer. So that was our part 2. Then we shall look at this as our part 3 now. This will be our part 3. So our part 3 says, during a maintenance inspection, the technician obtained the quadratic equation, which is 3x squared plus 9x minus 1, equaling to 0, whose roots are alpha and beta. After modifying the machine settings, he was advised to use a new equation whose roots are alpha to power 3 and beta to power 3, but he is finding it difficult. So that is our part 3 that we shall be looking at. So in part 3, they are saying he must use the equation whose roots are alpha to power 3 and beta to power 3, but he's finding it difficult. So what we need to do is to find this equation whose roots are alpha to power 3 and beta to power 3. So we need to form a quadratic equation whose roots are alpha to power 3 and beta to power 3. So we are given a 3x squared plus 9x minus 1 equaling to 0. So first we need to identify the sum and the product of the original roots. Now, if the roots were alpha and beta, so what will be alpha plus beta and what will be alpha beta? So to get alpha plus beta and alpha beta, you need to first divide through by 3. So it means x squared plus 3x minus a third will be equal to 0. So what will be the sum? Alpha plus beta. Alpha plus beta will be negative of this, and alpha beta will be negative a third. So that will be alpha plus beta and the alpha beta. Now, what would be the sum of the new roots? The new roots are alpha to power 3 and beta to power 3. So we must recall that alpha cubed plus beta cubed is equal to alpha plus beta to power 3 minus 3 alpha beta into alpha plus beta. So you already have your alpha plus beta, and your alpha plus beta is negative 3. So you will have negative 3 to power 3 minus 3 into alpha beta, that is negative a third, into negative 3. So this will give us minus 27. This will reduce this, minus, minus, minus. So that will give us a plus. Oh, minus. That will give us a minus. That will give us a minus. So this will be able to give us negative of 30. Next, we get alpha, the product of the new roots. That is alpha cubed times beta cubed, which can be written as alpha beta everything cubed. But you already have alpha beta as negative a third. So substitute it there, and you'll be able to get negative 1 over 27. So form the required equation, and the required equation is of the format x squared minus sum of the roots into x plus the product of the roots equaling to 0. So it means we shall have x squared minus the sum, which is negative 30, into x plus the product, which is negative 1 over 27, and this will be equal to 0. So that is basically what we shall have. And from here we shall have x squared plus 30x minus 1 over 27, which is equal to 0. So multiply by 27 through, and you'll be able to have 27x squared plus 810x minus 1 equaling to 0. So this will be the required response. So that will be our answer. So remember, he was advised to use a new equation whose roots are. So the equation whose roots, so you can give the conclusion that therefore the equation whose roots are alpha cubed and beta cubed is 27x squared plus 810x minus 1 equaling to 0. So this will be the required equation. So next, that is last 3, that is our last part, that is part 4 now. So in the accounts office, one of the accountants is estimating the cost of fuel used by the milling generators using the expression 2 minus x to the power 6. He requires the first 3 terms of its expansion in order to estimate the value of this, but he is unable to do it. So how do we respond to that? So before we come to that response, at TV Math, you need to be aware that there is an intensive Senior 6 Mathematics revision program that is ongoing. So the program is basically a revision program designed for Senior 6 students who are preparing for their mock examinations and their final examinations. So the program continues after mocks with detailed discussion and collection of examination papers. So this is basically what you'll be able to get. We shall have intensive revision of major concepts in mathematics, step-by-step examination techniques, discussion of different past papers, mock paper analysis, weekly practice exercises, marking guides, continuous feedback, and support in some of the areas where you are weak. So the duration is majorly from July to August, and this will be closing early September. So for details, simply give me a WhatsApp message or call on that number, and you can inbox for enrollment details. That is when you want to be part of the premium group. So you can contact me on any of these numbers here. They are all on WhatsApp. You can give me a call and we shall be able to talk at length. So let us look at the required response. So we are told that the accountant is estimating the cost of fuel using this expression. He requires the first 3 terms and also the value of this. So let us look at that one. Now, from the given information, we need to first of all try to rewrite. This in this form, because we know 2 minus x to the power of 6. This can be written as 2 into 1 minus x divided by 2, but the whole of this is to power 6. So this will be same as 2 to power 6 into 1 minus x divided by 2, then this is to power 6. So we recall that 1 plus x to the power of n is same as 1 plus nx plus n into n minus 1 x squared over 2 factorial plus dash dash. So if we have 1 minus x over 2 to the power of 6, so this will be 1 plus n is 6 into x, which is negative x over 2, plus that is n, that is 6 into 5 x squared, that is negative x over 2 squared divided by 2, plus and other terms. So that is what we shall have as this one alone, but there is 2 to power 6 out. So for that case, 2 to power 6 alone will be 64. So into, so we shall have the expansion for this is this, that is 1 plus 6 into negative x over 2. Then this one is 30 divided by 2, which is 15. And then this will be x squared divided by 4. And this is what we shall have. So from there, it means we shall be having 64 into 1 minus 3x plus, this is 15, x squared over 4 plus dash dash. So multiply through by 6. And when we multiply through by 6, you will have 64. And then 64 times 3, you will have you have 192, and then when you get 64, you multiply it by 15 over 4, you'll be able to get 240. So this is what you'll get as the expansion of 2 minus x to the power of 6. Now, we are interested in the first three terms. So the first three terms of this expansion will be 64 minus 190 minus 192x plus 240x squared. So next we need to estimate the value of this. Now, to estimate the value of this, you need now to put it in the format of this one here, which is 2 minus x. So looking at 1.998, this is same as 2 minus 0.002. Because when you get 2 minus 0.002, you'll be able to get 1.998. So we are putting it in the format that we have used here, which is 2 minus x. So you look at 1.998. How best can you express it in this form? So you need a value of x, which you can subtract on 2 to get 1.998, and that value is 0.002. So the value of x will be equal to that. So this can be estimated as, where there is x now in this expression, we shall put there as 0.002. So when you get 64 minus 192 into or times 0.002, then you add there 240 times 0.002 squared, then you should be able to get 63.61696. So the estimated value of this will be equal to that. So the actual value, of course, differs always slightly because higher order terms are very small. So basically, that is the estimated value of this one that we shall be able to get. So here are some of the important notes. In part A, the candidate should apply logarithm laws correctly before solving simultaneously. Since logarithms are defined only for positive values, the negative square root must be rejected. In part B, candidates should first express the inequality as a single rational expression and then use a sign table or interval method. They should state clearly that x equaling to 1 is excluded because the expression is undefined, as we have already seen. In part C, the candidate should be able to use this formula to obtain alpha plus beta and alpha beta followed by this identity. Should be able to use this identity correctly. In part D, candidates should rewrite the expression in the format this before applying the binomial theorem. And when estimating this, only use the first three terms as requested. So that is all about our item number 3. And if you have watched up to this given point, please, we already have TV Mathab A-level WhatsApp channel. And in case you are not yet part of that group, please join the group, the WhatsApp community, using the link in the description. So I will attach the link. I will put the link in the description. So please feel free to join. Joining is completely free of charge. Let us now look at part 2. And under this part, we shall basically be looking at the construct, which is called calculus. So part 2 has got 2 parts, that is item 4 and item number 5, all of which are in the construct that we call calculus. We have already looked at the different topics that fall under this part, and please, in case you have not watched the video regarding the structure of these papers, please find the link in the description for this same very video. Let us look at item number 4. So item 4 says, a curved road path was constructed with the equation y equaling to 4x plus x squared. The road bounds a swamp to a straight river mathematically with an equation equal to the x-axis. Urban planners want to know the area of the swamp bounded by the curved path to the straight river. Constructors want to use the coordinates of the maximum turning point as a center point of the circular junction that is going to be constructed at the top of the road. While planning for the junction, constructors believe that a 2% error was made in measuring the radius of the circular junction. They want to know the percentage error that would affect the area of the whole circular junction. Due to the poor sanitation in the city, urban planners are planning to construct an open tank to be used for collecting water. The tank is to be constructed with a horizontal square base and 4 vertical rectangular sides. It is to have a volume of 32 centimeters cubed. Urban planners want to find out the least area of the sheet metal to be used. Now, part A for the task says, help the urban planners to come up with a simple sketch of the swamp, total area occupied by the swamp, and the center point to be used. Help the urban planners to find the percentage error made in the area and the least area of the sheet metal to be used. So this is our task. We shall look at this task in different parts, and the first one will be basically to look at the area. So urban planners want to know the area of the swamp bounded by the curved path to the straight river. So let us look at the required response. Okay, so basically this is our item 4, and we are told that a curved road path was constructed with this equation. The road bounds a swamp to a straight river mathematically with an equation equal to the x-axis. Urban planners want to know the area of the swamp bounded by the curved path to the straight river, and that is what we shall be looking at as our part 1. Now let us look at how best we can respond to this item. So we need to sketch the curve and determine the area of the swamp and identify the center point. So the curved road is represented by y, which is equal to x squared plus 4x, while the straight river is represented by x-axis, which is actually y equaling to 0. Now we need to determine the points where the curve meets the x-axis. So we need the point of intersection. So the point of intersection are the x-intercepts occur where y is equal to 0. So therefore, you are having these two. You have y equaling to 0 and y equaling to x squared plus 4x. So you need the point of intersection between the two, and that is obtained by solving the two simultaneously. So where there is y, I will put a 0. So that's why we have x squared plus 4x equaling to 0. Solving this, you'll be able to get x equaling to 0 and x equaling to negative 4. That is what we shall be able to get. So therefore, the curve cuts the x-axis at 0, 0, that is 0, and y will also be 0, then negative 4, and y will also be 0. So these are the points of intersection. So these are the points where the swamp begins and ends. So next, since we need to sketch, we need to get the turning point for the curve. So the given point is obtained by finding the stationary point of the curve. So what we shall do is we shall differentiate this. When we differentiate this with respect to x, we shall get 2x plus 4. So at the turning point, dy dx is equal to 0, and you'll be able to equate 2x plus 4 to 0, and you'll be able to get x as negative 2. At that point, we need to get the value of y. So substitute it into the equation of y equaling to x squared plus 4x. So when we substitute it there, we shall be able to get at the turning point as negative 2 and negative 4. So this is our turning point, and now we shall look at the nature of the turning point. So to get the nature of the turning point, we shall differentiate again. So when you differentiate again, you'll be able to get the 2y dx squared as 2, because we are differentiating at y dx, and y dx is 2x plus 4. So differentiate this again, and you will get a 2. So 2 is greater than 0, so the curve is a concave upwards. So therefore, the stationary is a minimum turning point. So after getting the minimum turning point, remember they are saying urban planners want to know the area of the swamp, okay? Then constructors want to use the coordinates of the maximum turning point as a center point of the circular junction. So looking at what we are told, what we have got is a minimum turning point. Now, the question says, the question refers to the maximum turning point, but this is mathematically incorrect because the parabola opens upwards. Hence, the turning point is a minimum point. So from the given information, or what we are told, is the constructors want to use the coordinates of the maximum turning point, and from what we have seen, that this shouldn't be the maximum. Actually, it should be the minimum. So that should be a small error. So it should be a minimum. Now, so our point that we have got as our minimum point will act as that center of the circular junction. That will be the center of the circular junction. Now we would like to sketch this curve. So let us see how best we can deal with the sketch. So we have got for for y-intercept, we need to also get the y-intercept before that. Okay, so okay, let us see. What we have got is the turning point. We have it. We have for the x-axis, we have the points where these ones meet. So we can also go on and get for y-intercept, we get the intercepts. So for the intercepts, for y-intercept, x will be 0, meaning that y will be same as 0 squared plus 4 times 0, substituting in the expression for y, this one here, so you'll be able to get y as 0. So the intercept will be 0, 0. So 0, 0 is the intercept. Then for the x-intercept, y is 0, and we have already seen that the intercept also, that is for the x-intercept, where y is 0, we have also seen that we have 0, 0, and negative 4, 0. So those are the points that we need to sketch. Also, another one that we did, we shall also look at the nature. So for when x is tending to positive infinity, where will y be tending to? So when you look at x squared here, this one determines the nature of y. So because that is the highest power. So if we put x as positive, y will be also positive. Now, for x tending to negative infinity, where will y be tending to? Y will be tending to, when you substitute here the value of x as a negative, since this is squared, y will be positive. So y will still be positive. So those are some of the things that we need to sketch. So we need to put the points. We have 0, 0. So this is point 0, 0. We need to put negative 2. This is our negative 2. So negative 4 can be around here. So this is negative 4. So this point will be around there. This is the point negative 2, negative 4. Another point that we shall need is this one here, which is negative 4, 0. So another point will be negative 4 and 0, this point. Okay, and in this region here, y is positive, so y goes that side. In this region, y is tending to negative, as x is tending to negative infinity, y will be tending to positive infinity. So the intercepts, we have put them. Where y is tending, we have put that. The intercepts, we have put that. The turning point, we have put it, but the turning point is a minimum turning point. So we shall now draw our curve. So when we draw our curve will be, in this one will be positive, in this one will be positive. So our curve should be coming like this. And when it reaches here, it should turn from here upwards. When it reaches in this region, it should be positive. So it should be looking like that. So this is our y equaling to 4. This is y equaling to, so this will be y equaling to x squared plus 4x. X squared plus 4x. So x squared plus 4x. So this will be the way we shall be drawing our curve. So this is y and this is x. So the swamp is in this region, so which is bounded by the x-axis and this y equaling to x squared plus 4x. So at the center, as we have seen, is this one here, negative 2, negative 4. And we need the area. As you can see, the area here of the swamp will be negative because it is below the x-axis. So now, having sketched this curve here, we can now look at the required area. So the area is the area which is bounded by the x-axis and this curve here. So again, it is from the point that is from x equaling to 0 up to negative 4, or it is from negative 4 up to x equaling to 0. So the smallest value is negative 4 to 0. So we shall be integrating from negative 4 to 0. So let us look at the required area. So we need to determine the area of the swamp. So the area of the swamp, by definition of area is same as the that is from x equaling to a to x equaling to b of y dx. But this y is a function of x. So for us, we shall be integrating from negative 4 up to 0 of our y, which is x squared plus 4x dx. We are putting this negative simply because the area that we are looking at is below the x-axis. So you can put the minus such that the minus you will obtain from here will cancel with this one and it gives you a positive. Another alternative, someone can look at the area. You simply take from negative 4 to 0 of x squared plus 4x then dx. Then the area you will get here will be a negative area, but when you are giving the conclusion, you have to give with the positive value because it is below the x-axis. So those are two different ways of how you can answer that. So here we are including the negative simply because the area that we are looking at, is below the x-axis. So that is the part that we have put here, that many candidates omit the negative sign and obtain a negative area for the negative value for the area, but area cannot be negative. So what we do, you either put the negative value of the this value here such that the negative will cancel with this negative, or else you take the magnitude of this one, which will be the same thing. So that is what we have said here. So we have said that since the area lies below the x-axis between the intercepts, therefore the area enclosed is negative of this one here, where the negative sign is introduced because the curve is below the x-axis. But in case you don't introduce the negative, you can go on and get the area as the negative, but give the conclusion with a positive value. So that is what I will emphasize there. So the area is from negative 4 to 0 of x squared plus 4x dx. So integrate this one here, integrate x squared plus 4x. Then this will be x to the power 3 divided by 3 plus 2 x squared, because this will be divided by 2, increase the power by 2. So put the limits. So the area will be, when you put the limits, you have a negative out. So put 0, everything will be 0, minus, put negative 4 to power 3 divided by 3 plus 2 into negative 4, which is a squared. So you'll be able to get a negative of 64 over 3. Then this minus is there, and this minus will give you a positive. So you will have a negative 64 over 3. Then this one will be plus 32. So get the LCM, and this will be able to give us negative 64 over 3. Then plus the LCM, get the LCM at once. So this will be 3. 3 divided by 1 is 3. 3 divided by 3 is 1 times this remains. 3 divided by 1 is 3 times this. That will be 96. So get 96, subtract this, and you'll be able to get 32 over 3. So the area will be 32 over 3 square units. So that will be the area. That will be the area of the swamp. So from here you will directly get a positive value. But for someone who does it in this way, will be getting the area as negative 32 over 3. So the person who does this, you will also have x to the power 3 over 3 plus 4x squared over 2. So put your limits, negative 4 to 0. So when you do that, you'll be able to get, put a 0, that will be 0 minus. So put a negative 4, that will be negative 64 over 3. This will be plus 32. So this will give us a negative of, when you get the LCM here, this will be 32 over 3. And this will give you negative 32 over 3 square units. This will be your area. But when you are giving the final answer, you must give the answer that the area of the swamp is, the area of the swamp is 32 over 3 square units below the x-axis. So you give the area as the positive value. So that is why we introduced this minus. So that shouldn't confuse you. So from there, we shall be able to get the area of the swamp as 32 divided by 3 square units. So from there, we can give the conclusion. So urban planners want to know the area of the swamp bounded by the curved pass to the straight river. So give the conclusion that therefore the area of the swamp is 32 square units below the straight river. So you can say below the x-axis or below the straight river. Below the straight river. So that should be your answer. So next we need to state the center point of the circular junction. So the constructors wish to use the turning point as the center. So therefore, -2 and -4 is the required center point, because they are saying constructors want to use the coordinates of the maximum turning point, but as we have seen, this should be the minimum turning point as the center of the circular junction. So the center of the circular junction will be -2 and -4, because this is our turning point. So these are some of the comments. The candidates should, 1, find the x-intercepts by setting y equaling to 0. You must also talk about the turning point. You must classify the turning point, and you must be able to state the parabola, that the parabola opens upwards and therefore has a minimum turning point. You should as well recognize that the curve lies below the x-axis between x equaling to -4 and x equaling to 0, and account for this when evaluating the area. So when evaluating the area, you must account that as the curve lies below the x-axis, and you must be knowing what to do there. So you should be able to produce a neat sketch that is showing all the features, including the intercepts, the turning points, the axis of the symmetry, a shaded part or region, and correctly labeled axis. Then you should also comment on the phrase that we were given the maximum turning point usually. This was what was given in the question. However, that is mathematically incorrect, because the correct description should be a minimum turning point. So that should be your comment, as we have seen above. So next we would like to come to the other part. So they are saying, while planning for the junction, constructors believe that a 2% error was made in measuring the radius of the circular junction. They want to know the percentage error that would affect the area of the whole circular junction. So we are dealing with a circular junction. And since we are dealing with a circular junction, we are told, so we are given that while planning for the junction, constructors believe that a 2% error was made in measuring the radius of the circular junction. They want to know the percentage error that would affect the area of the whole circular junction. So we already have the center of the circular junction. So from that, since we already have the center of the circular junction, we shall now look at how best we can get the percentage error that would affect the area of the whole circular junction. So what we shall do here, let us look at the percentage. That would be B part 1. The percentage error in area. The percentage error in area of the circular junction. So the percentage error of the circular junction is what we need to look at. So first of all, this is a circular junction. So what will be the area of the circle? So the area of the circle will be given as pi r squared. So when we differentiate this, dA dr will be same as 2 pi r. That will be same as 2 pi r. So next, this means that dA will be same as 2 pi r, then dr. Now, what we shall do here is we shall now get dA, we divide it by a. So when you get dA divided by a, this is same as 2 pi r dr divided by area, which is pi r squared. So dA over a will be same as, so this and this will cancel. So this and this cancels. You will remain with 2 times dr over r. That is what we shall have. So we are given that constructors believe that a 2% error was made in measuring the radius of the circular junction. So the 2% error was made. So what does that one mean? So it means that if I have this expression here, I can get the percentage by simply multiplying through by 100. So when you look at this one here is the percentage error in, this will be the percentage error in measuring the radius of the circular junction. So what will that one give us? It will give us 2 times this was given as 4. So it means the A over A times 100 will be equal to that. So since the percentage error in radius was given as, let us check, it was given as 2, not 4. So it was given as 4, as 2, not 4. So this should be 2. So for that case, it means that the percentage error in radius, the percentage error in radius is 2. So we have put it there. So the percentage error in area will be equal to 4%. So that will be the percentage error in the area. So from that, they want to know the percentage error that would affect the area of the whole circular junction. So the percentage error in area is 4%. So this will be the percentage error that would affect the whole circular junction. And that part will also be answered. So that is how we shall get a B part 1. Then next we need to look at, due to the poor sanitation in the city, urban planners are planning to construct an open tank. So let us look at this part here. So this will be like our part 3. So this is our part 2. And this will be our last part of this item. So let us look at that. So we are told that due to the poor sanitation in the city, urban planners are planning to construct an open tank to be used for collecting water. The tank is to be constructed with a horizontal square base and 4 vertical rectangular sides. It is to have a volume of this. So it is an open tank with a square, a base, and 4 vertical rectangular sides. So looking at that, we have a square base, and we want to let the side of each base, because this and this and this are all equal, and the 4 sides, that is 4 rectangular, 4 vertical rectangular sides. So we have 4 vertical rectangular sides. This, we have that, we have that. So these are the 4 rectangular sides. So it means when you join that, it should be in that format there. So it is open, so it means this will be like that. Okay, so this is open. So these are the 4, these are the, okay, let us see. So 4 vertical rectangular sides. So those will be the 4 rectangular sides. So we are letting the height, this one here, to be h. Each of these sides is x, so this will be x, and this will also be x. So that is basically what we shall have. Now we need to find the equation of the volume. So we are told that the volume is 32 centimeters cubed. So if you have as such, when you look at this one here, then you realize that this will be the volume, length times width times the height. So the volume of our shape here will be length times width times the height. So the length is x, the height, the width is also x, the height is h. So volume will be x squared h. That will be the volume. Now we are given that this volume is 32. So meaning that x squared h is equal to 32. And we can get our h as 32 divided by x squared. So that will be h in terms of x. Next, we are told that we need to deal with the area, because urban planners want to find out the least area of the sheet metal to be used. So we need to obtain the surface area. So let us look at the surface area. So looking at the surface area is the base plus the 4 sides. So we shall be getting this one. Remember, it is open. So this would have been the one on the other side, but we shall look at only this, since this one here is open. So we shall only have the base. We shall only have this part here, this side here, and this side here. For each of these sides, then there is an opposite side. which also is of the same format. So that's why we shall have the area will be the base area, the base which is this, then plus the four sides. The four sides we have this one here, but this one has the opposite side, and this one here which also has the opposite side. So when you look at this side is here, it has this one x and the height this one here. So for that case, we shall be able to get the area as x squared plus 4xh, because the area, the surface area of this side here, the surface area of this side, the surface area of this side will be, so the area will be same as x times h. So as you get the surface area of this, the surface area of this, it will be the same as this one here. But for each of these sides here, they are opposite sides. They are opposite sides. So it means in total there will be 4 of them. So it means we shall have this and its opposite side. We shall have this and its opposite side. So those will be 4 sides that we shall consider this, this one and their opposite sides. So that's why we shall have the area as 4 times xh, because each will have the area of x times h. Then the base is a square, so it will be x times x, which will be x squared. We would have added this one here, but now this one is not there, so this is open. So we shall only take for this one here. We shall not take the opposite side. So that's why we shall have the x squared plus 4xh. So that will be the surface area. So we are doing that because the tank is open. Now we are saying area is x squared plus 4xh, but we have already got our h as 32 divided by x squared, which means that area will be x squared plus 4x then times h. So it will be x squared plus 4x times h, which is 32 over x squared. So this will give us x squared plus 4 times 32, that will be 128 divided by x. So this will be the area. So from there we shall differentiate. So you will differentiate this. When you differentiate this with respect to x, so this will give you 2x, but this one here can be written as 128x to power negative 1. So drop this, this will give you minus 128x to power negative 2. So that is why we shall have this. So for the minimum area or the least area, we shall get a dA, dx, and we equate it to 0. So when you equate this to 0, you should be able to have this. So multiply through by x squared, and it will give you 2x to power 3 is equal to 128. So x to power 3 will be equal to 64, and this will give you x as 4 centimeters. You can go on and check if it will be able to give you the minimum value. So you can as well get the second derivative, the 2 dx squared, which will be same as, so this one here can be written as 2x minus 128x to power negative 2. So this will be same as when differentiated. When you differentiate that, when you differentiate 2x minus 128x to power negative 2. So this will give us 2 minus, drop this one here, that is minus again, that is minus 2, then x to power negative 3. So this one will give us 2 plus 2 times 128 over x to power 3. So as you can see, for x equaling to 4, the whole of this one here will give us a positive value. So for x equaling to 4, the 2a dx squared will give us a positive value. That is a value which is greater than 0. So for that case, it means x equaling to 4 gives minimum area. Gives minimum area. And that is what we shall have. So after getting x equaling to 4, go on and get the value for h. So the value for h is 32 divided by 4 squared. That will be 2 centimeters. That will be 2 centimeters. So confirm it is a minimum. We have done that, and we can easily see that the stationary point is actually a minimum. So from there, get the least metal area, and that will be substituting 4 in the expression for the area, which is x squared plus 4xh. X squared plus 4xh. So that is what we shall do. So remember, your area is x squared plus 4xh, or else you can simply substitute in this, which is already simplified. X squared plus 128 over x. X squared plus 128 over x. So put x equaling to 4, and you'll be able to get 48. So it means the least amount of the sheet metal that is required is 4 centimeters cube, as 4 centimeters squared. And this occurs when the base has the side equaling to 4 centimeters and the height is 2 centimeters. So that will basically be the required answer. So these are generally the answers: the turning point or the center point we got, the area of the swamp, the percentage error in the area, and the what we call the least metal sheet. So what are the examiner's comments? Candidates should factorize the quadratic correctly to obtain the intercept, complete the square, or use the vertex formula to determine the turning point, recognize that the parabola opens upward and therefore has a minimum turning point. So include a negative sign when evaluating the area, since the curve lies below the x-axis. Should be able to apply the differential approximation, that is dA over A is equal to dr over A. So for the percentage error questions. Then next, you should be able to express the surface area in terms of one variable before differentiating, and verify that the stationary value is a minimum using the second derivative test. So that is basically what we shall have, and that brings us to the end of item number 4. If you are here for the first time, please make sure you subscribe to TV Math Hub. Subscribing is completely free of charge, but you will always get notified whenever a new video is uploaded. For any inquiries, or you are interested in our services for TV Math Hub, please simply give us a call or WhatsApp on any of these numbers. And there is an intensive Senior 6 Mathematics revision program that is ongoing. If you want to be part of it, so you can benefit like others, please make sure you send me a message from or using any of these contacts here. We also have a WhatsApp group community that is already operational, and the entrance is free of charge, but you will get a lot of revision papers, practice items, discussion with other students. So please make sure you be part of this. So you don't need to read alone. You need to read with a group of very enthusiastic students, and that is what we shall be providing to you. So if you want to join our WhatsApp community, simply give me a call or simply give me a message on WhatsApp using any of this, and you will be added to the WhatsApp group immediately. So let us look at the next item, and that will be item number 5. Let us now look at the last item, that is item number 5, and this item comes from calculus, as we have seen for item 4. So it says James works in a company on a machine which produces a certain commodity continuously according to the model, that is f of t equaling to t squared divided by t minus 1 into t plus 2 for 3 less or equal to t less or equal to 5, where t is the time in hours, so that the management can be able to determine the mean production rate so as to improve efficiency and productivity if the mean production rate is greater than 0.5. So next, they are saying James has a container which contains a solution of salt in water. Initially, the container contains 1,000 liters of water with 10 kilograms of salt dissolved in it. The mixture is powered off at a rate of 20 liters per minute, and simultaneously pure water is added at a rate of 20 liters per minute. All at the time, the container is stirred to keep the mixture uniform. James is interested in finding the mass of salt in the container after 5 minutes, but he is finding it difficult. So part A of our task is to help James to find out whether the management will improve efficiency and productivity or not. Part B is to help James to find the mass of the salt remaining in the container after 5 minutes. So let us look at the required response. So looking at what we are given, we shall begin by looking at the first part. So the first part says that James works in a company on a machine which produces a certain commodity continuously according to the model, that is f of t, which is equal to this, where t is the time in hours, so that the management can be able to determine the mean production rate so as to improve efficiency and productivity if the mean production rate is greater than 0.5. So let us look at the required response. So we know that the production rate of the machine is given by this, where T is the time in hours. So the management needs the mean production rate over this interval. Now, we need to look at the formula for the mean value of a function. You need to recall that for a continuous function f of t over the interval a less or equal to t less or equal to b, the mean value is given by 1 minus b, 1 divided by b minus a, the integral of a to b f of t dt. So therefore, it means that mean production rate will be same as 1 divided by 5 minus 3, like the way this is given. Then from 3 to 5 of our f of t. Our f of t is given as this. So that is what we shall place there. So we are dealing with mean value of this given function. And the mean value of a function over an interval a to b is given by 1 over b minus a, integral of a to b f of t dt. So mean production rate will be also in the same way. So we shall have 1 divided by 5 minus 3, integral of 3 to 5 over this. So looking at this now, we shall simplify it and it becomes 1 over 2 integral of 3 to 5 of t squared upon t minus 1 into t plus 2. So when you look at this, we need to integrate this. But before we integrate this, we need to express this into partial fractions. But when you look at this, this is an improper fraction because the power of t here is equal to the power of t when you expand this, because the highest power here in the denominator will also be 2. So what we do, we can first expand this and we get t squared. T, that will be t squared. This will be 2t minus t minus 2. So that will give us t squared plus t minus 2. So what we shall do is we shall use the wrong division. So we shall use wrong division. So we are having t squared. This is t squared plus t minus 2. So we need to place here 1 such that this becomes t squared plus t minus 2. And when you subtract, this will give us negative t, then plus 2. That is what we shall have. So for that case, we can have this as 1 plus negative t plus 2 divided by t squared plus t minus 2. But this can be written as 1, then a minus of, I want to pull out this minus. When you pull out this minus, it will be minus of t minus 2. So this is t minus 2 over t squared plus t minus 2. So that is what we shall have here. So t squared over t squared plus t minus 2 will be same as 1 minus t minus 2 over t minus 1 into t plus 2, because this is same as this. Is same as t minus 1 into t plus 2. So when we put this one where there is t squared over t squared plus t minus 2, then it means when we are integrating t squared upon t squared plus t minus 2, we shall be having like integral of 1 minus t minus 2 upon t minus 1 into t plus 2. So again, we shall try to put this one here in partial fractions. So when we try to decompose this into partial fractions, we realize that the denominator has got linear factors. So that's why we shall have a over t minus 1 plus b over t plus 2. So from there, you can reach here and try to eliminate this and this, or else you can expand this and equate the coefficients. So from here, you can as well say for t equaling to 1, we can eliminate b, and this will be negative 1, which is equal to a into 3. So your a will be negative a third. You can eliminate this by putting t as negative 2. So when you place negative 2 there, this will be negative 4, which is equal to a will cancel out. This will be b into negative 2 minus 1. So negative 4 will be equal to negative 3b, giving us b as 4 divided by 3. So that will be the value of b, and this will be the value of a. Or else you can equate the coefficients like the way we did here. Put a and b, those are the coefficients of t. Then the constants, you have 2a minus b. So equate the coefficients and you'll be able to get the same value of a and b. Now from there, we have a, place it there, we have b, place it there. So when you do that, then you come back to this equation. where we have t minus 2 over t minus 1 into t plus 2, then you will place there this bracket here. So that one has been decomposed to give us this plus this. Now you can open this bracket for the minus, and this will give us 1 plus 1 over 3 into t minus 1 minus 4 over 3 into t plus 2. That is what we shall be able to get. Now, for when a person reaches here, you have two different options. One, you can take this, you can maintain this as a plus, and you remain with negative t plus 2, or 2 minus t. Then you will be able to get a as a third and b as negative 4 over 3. So you will still be able to get the same f of t as this. For you will be able to get a third and negative 4 over 3. But for someone who pulls out this minus and removes this plus such that you are able to have this, then you'll be able to get your a as this and your b as that. So that shouldn't be a point of confusion. Now, how do we integrate f of t? F of t is same as integrating this. So when you integrate one, you get t. You integrate a third 1 over t minus 1 dt. So when you integrate this, you get a third ln of t minus 1. So we put a minus, we put a magnitude to avoid a negative value there, because we cannot get ln of a negative value. Now, for this one here, we shall be able to get a negative 4 over 3 ln of t plus 2. So I shall be able to get this as our value. So go back and now put the limits 3 to 5. So when you put the limits 3 to 5, you should be able to put the upper limit. When you put the upper limit, that will be a 5 plus a third ln 4 minus 4 over 3 ln of 7. So you are substituting for t equaling to 5, then after you subtract for t equaling to 3. So you'll be able to get this given value. So this will be the integral of 3 to 5 f of t will be equal to that. But remember that our expression is the mean production rate is a half the integral of this. So the integral of this around is what we have obtained. So you will now multiply by that a half. You will now multiply by that a half, and you should be able to get the mean production rate as this. Now, for the judgment, they are saying the required condition is that the mean production rate should be greater than 0.5. And surely, this value here is greater than 0.5. So it means the company should proceed with improving efficiency and productivity. So that will be the required response for part 1. So this will be our first part. So this is our part 1. So the next part, which is part 2, they are saying James has a container which contains a solution of salt in water. Initially, the container contains 1,000 liters of water with 10 kilograms of salt dissolved in it. The mixture is powered off at a rate of 20 liters per minute, and simultaneously pure water is added at a rate of 20 liters per minute. All the time, the container is stirred to keep the mixture uniform. James is interested in finding the mass of salt in the container after 5 minutes, but he is finding it difficult. So that is basically what we need to look at. So we need to determine the mass of salt remaining after 5 minutes. Now, initially, we are given the volume of the solution is 1,000 liters. Okay, and it has 10 kilograms of salt dissolved in it. The mixture is powered off at a rate of 20 liters per minute, and simultaneously pure water is added at this rate per minute. So we are given the volume of solution as 1,000 liters. Mass of the salt is 10 kilograms. Mass of the salt is 10 kilograms that was dissolved. Now, salt lives at this rate, that is 20 liters per minute. So we are told that the mixture is powered off at a rate of 20 liters per minute, and simultaneously pure water is added. Now, simultaneously pure water enters at the same rate. So it means the volume remains constant, because the solution that is removed is 20 liters per minute and pure water enters at the same rate. So therefore it means the volume remains constant, which is 1,000 liters. So what we shall do is we shall define the variable. We shall let S of t to be the mass of the salt in kilograms after time t minutes. And then we shall be able to form the differential equation. We are saying pure water enters, and therefore the salt entering will be 0 as pure water enters. Therefore, the salt entering will be 0. But what will be the salt leaving in the concentration? So the concentration of salt is S of T divided by 1000. Because if the solution is powered, they are saying that the mixture is powered off at this rate. So if the mixture is powered off at that rate, then we must look at the salt that will be leaving. Remember, the total volume is 1000. So if S of T is the mass of the salt in kilograms after time T, then it means the concentration of salt will be S of T divided by 1000 kilograms per liter. So the outflow rate is 20 liters per minute. Is 20 liters per minute. So it means the salt that will be leaving in the 20 liters per minute will be the 20 times the concentration of salt, which will be S divided by 1000, and this will be able to give us S divided by 50. So this is this will be the ds dt. So the ds dt will be same as negative of S over 50, because this is the salt that will be leaving. So the outflow rate is 20 liters per minute, and within the 20 liters, then we shall be having the salt as 20 times S over 1000. So it means ds dt will be equal to the rate at which the salt is leaving, and that is negative S over 50. So from here, you separate the variables, and that will be ds over S, which is equal to negative dt over 50. And now you can integrate on both sides. So integrating on both sides, you'll be able to get ln of S, and then this will be negative of 1 over 50t plus c. So from here, you can bring the ln this side, and S will be e to the power of t over 50. This is negative, then plus c. So S will be same as a e to power negative t over 50, where this a is representing e to the power of c, because this can be written as e to the power of negative t over 50 times e to the power of c. So this will be S at time t. But they are telling us that that initially the salt that we had was 10 kilograms. So S of 0 is 10. So it means where there is t, we shall put 0. So it means 10 will be equal to A, and this will be our expression for the S. So we need to find the salt after time, which is 5 minutes. So at t equaling to 5, then substitute 5 here. So it will be 10 e to power negative 5 over 50, which will give us approximately 9.05 kilograms, or which you can write as this will be 9.048 kilograms. So that would be the salt, that will be the mass of salt in the container after 5 minutes. So the mass of salt in the container, after 5 minutes, is 9.048 kilograms. So that will be at the end of our item number 5. So what are some of the important comments? So the candidate should use the formula this when finding the mean value of a continuous production rate. So when you forget to put 1 over b minus a, that would be wrong. So you need to simplify the rational functions before integration using the polynomial, long division, and partial fractions. Then you need to compare the calculated mean rate with the required value, which is 0.5, before making the judgment. Then for the salt, problem, you need to recognize the volume remains constant because the inflow and outflow rates are equal. Then you need to form the differential equation from the rate of change, that is the rate in minus rate out. And you must use the concentration, that is mass of salt, over the volume of the solution to obtain the salt outflow rate. And after that, you apply the initial condition correctly to determine the constant of integration. So that's all that we can talk about on item number 5. And that will bring us to the end of our today's paper, and that was That was Kamasa. That was Kamasa Mock. And if you find this video very helpful, please don't forget to subscribe to this channel. Don't forget to give us a like. Don't forget to share this video to all your friends. God bless you all. We meet in our next videos.